is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff of Falcon 9. Falcon 9 is clear to tower.
First stage propulsion nominal.
Hey, physics fans, welcome back. That was the first 26 seconds of launch of the Falcon 9 way back in June 2017, I believe it was. Let's just go over a rocket launch. At launch, the Falcon rocket accelerates at 15 meters per second up from the launch pad. What is its thrust force? Now, amazingly, the rocket weighs 25,000 kilograms and it carries this much fuel, 523,400 kilograms of fuel. And then the payload at the top can be a maximum of 22,800 kilograms. So the total weight of the rocket at launch is 571,000 kilograms. Okay, that's just an approximation, and there's always these things change every launch. But there it is. That's amazing. And they burn up the liquid oxygen and the propellant. In this case, the propellant is rocket-grade kerosene, and they mix them together and explode it, and yowzers. And that's shooting out the gases so fast. And Newton's third law is, as it pushes on the gases fast, the gases push back on the rocket. And the forces on the rocket are what we're looking at. The forces act on the rocket. So the forces acting back on the rocket is called the thrust force. That's how much thrust it really pushes down with. And then there's the weight of it. And then if we are going to include friction force, which we're not in this question, there is also a drag force down. But there's a force of gravity down, so that is the cartoon version of the free body diagram. And our free body diagram will be, we'll have the thrust force up, and the force of gravity down. And that's it. Now I'm going to box that off and show you that it is accelerating this way. If it's accelerating that way, which one's going to be bigger? Yeah, the thrust force. Very good. Okay. So let's go ahead and do it. Let's see if we can, okay? Let's just make this a little bit smaller so we have some room here. Okay, so the sum of the forces is equal to F net equals MA. That's how you'll always start forces questions. It's the forces. And what's the formula for it? Newton's second law. Now the forces. If this is going up, this one is bigger, so that one's winning. So you always take the winning, subtract the losing. The winning, subtract the losing. Force, thrust. If you take the winning, subtract the losing, your acceleration will always be positive. And force of gravity is down, and that is MA. Now the force of gravity is mg. You don't know that yet, but I'm going to do that for you right now. And that's 571,000. And that's m, and g is 9.8. And so the force of gravity is Dun, 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 calculator up. It is 571000 times 9.8. So that's 5,595,800. 5,595,800 newtons, or you can go 5.5958 times 10 to the 6th newtons, or 5.59, let's do 6 meganewtons. Anyhow, that's, if you didn't know the formula, which I don't think you have because you haven't seen that lesson yet, that's how you get the weight. So the thrust is what we're trying to find out. What is this thrust force? So force, thrust, put an R in there, minus force of gravity, 5.5958 times 10 to the 6th is equal to its mass. Mass is 571,000 kg. And the acceleration is 15. Okay, we move that over to the other side, multiply those together, and add that number. So we take 571,000 times it by 15, and that's the MA. It's an important number to write down. 8565000. Why is that an important number to write down, which is just the product of these two? Because it's MA, which is the net force. Sometimes the question will be part A, part B, part C, and one of them will definitely be asking for the net force. And then we have to add this 505,95800 newtons. So we add that number up there, and that'll be the thrust force. Now, if you're having problems understanding it, it's probably because these numbers are so big and confusing. The main thing to understand here, as you're going through and calculating it, is understand this is where you start. Then you look at the free body diagram and you take the winning, subtract the losing, and that equals MA. So the winning, subtract the losing, that equals MA. Now you just have to plug in the numbers. And now I should have actually not said the mass of this. I should have given you the weight of this, which is this number here, instead of confusing you by throwing in a little bit of calculation here. So if I gave you this number, if I gave you this number, this number, this number, which I did, then away you just plug it in and do it. Excellent. So let's just, for the final, let's watch the amazing landing of the Falcon 9 and then the tunes. Let's watch that amazing 1-minute landing of it. It blows me away. Subscribe. Thanks.
Stage 1 is transonic. Stage 1 mini burn starting. Stage 1 landing racing point. Stage 1 engines have shut down. LZ1, the Falcon has landed. Landing operators proceed with initial safing per procedure 11.100, section 3 on LZ1 net.